Okay, folks, so welcome back. And in this video, we're going to talk about another laboratory for this semester. And the laboratory is going to focus on a drug component, and the drug is called Panacetin. Now, Panacetin is a fake drug. It's not really real. And Panacetin is a very small play on words. And the reason that I say that is because a term has been used for many, many years. And if you're a Final Fantasy role player fan, you will notice that panacea is often used in those types of games. And whenever you use a panacea on your character or the hero of the video game, you're going to see that all the ailments go away. Anything that's basically making them sick or making them poison will disappear. So they've decided to take this word of panacea and change it to Panacetin, and this is a drug that we're going to give you to do various testing on it. Okay? So this drug is made up of 3 components. And the first component is something called sucrose. And I'm going to put in parentheses here, that's otherwise known as sugar. Everyone loves some sugar. The second component that's going to be involved in the Panacetin is acetaminophen. Yeah, that's a long word to write out. So acetaminophen should be present. We know that it's there. We're just going to have to figure out how much. And then the third one that should be present is something called aspirin. So sucrose, acetaminophen, and aspirin. Now, these 3 should have various milligrams or around about average milligram in every single pill that we take. The problem, though, is that due to the manufacturing process, when people make pills, they cannot give you exact numbers. So there's going to be a leeway here. It's going to be a number plus or minus a certain percentage. So the expected values for these things, according to the book that you have, if you read the background, is that sucrose should be present in 50 milligrams, acetaminophen should be present in 250 milligrams, and aspirin should be present in 200 milligrams. And only these three things should be present. Well, if you add all this up, 250 plus 50 plus 200, that's going to be 500 milligrams in total. Okay, so the issue here is that we're given a drug called Panacetin, and we just want to make sure that these values are representative of the sample that we get. That's really what we're after here. So the question, or the lab, as far as procedure goes, is going to want you to calculate the percentage of each component in the sample. So in order for you to do that, you're going to have to figure out how many milligrams you have of each one, which means that we're going to have to separate these 3 things, right? That kind of makes sense. We'll have to separate them one by one, figure out the number of milligrams that are present, calculate a percentage, and then compare that percentage to the expected percentage. And the expected percentage is right up here. So I can take 50 divided by 500, multiply by a 100, and I would get a percentage of sucrose that it should be. I take 250, divide it by 500, times it by 100 because we want percentage here, and then that will give me the percentage of acetaminophen. And then finally, I would take the milligram of aspirin, divide it by 500, times 100 because we want percentage, and that will give me an expected percentage of aspirin that should be present in the pill. All right, so before I go further, I want to talk a little bit about each one of these. I want to talk about sucrose, acetaminophen, and aspirin. And we're going to start off with sucrose because it seems like that's what most people are comfortable with because they are familiar with the word sugar. Okay, so let's take a look at sucrose. So sucrose is a sugar. I first want to say that. There's plenty of sugars out there for your little teeth and tongue to bite into and salivate in. Sucrose is just one of those. So sucrose is a sugar, and sugar is also classified in a laboratory environment and in upper level chemistry courses as a saccharide. So saccharides are just very fancy terms that mean sugar. That's it. All right, well, sugars can come to us in just one version, meaning that if I have one sugar molecule, this is going to be called a mono, for one, saccharide. And that is an A there. So a one sugar chemical structure is a monosaccharide. All right, but let's say that I've got a molecule that's out here, and let's say that that molecule is attached to another one, and they're kind of holding hands a little bit. And this is a sugar, and this is a sugar. And they can be the same sugars. Doesn't really matter. Or they can be different sugars. Who cares? But they're two sugars holding hands with each other. Well, we have a nice little couple, a little sugar couple. And that now is called a disaccharide. Okay, 3 of them would be called a trisaccharide. 4 of them would be called a polysaccharide. 5 of them would be called polysaccharides. So everything up from 4 or more would be termed a polysaccharide. Now, that's not the only name that we can give these sugars. Saccharide is just one of them. So another name that we could use that also represents sugar, if I didn't want to use the term saccharide or the term sugar, would be carbohydrate. So nothing new. You've probably heard of carbohydrates before, and this is really where the Atkins diet first came into play because they were like, don't eat any carbohydrates. So people would not really eat any type of bread, any type of potato, because those were carbohydrates, and those carbohydrates are also known as saccharides, which are also known as sugars, and those carbohydrates will eventually turn into sugar through your metabolism process. So if we could limit those types of things, and we could force your body to burn up the carbohydrate that it currently has stored, people would lose weight, and they would lose weight pretty quickly. So that's why you kind of saw people turn away from the bread, but they ate the hamburger and not the hamburger bun, right? They ate a pack of bacon in the morning, but they did not drink any kind of orange juice. Okay, so that's a little bit of dietary information for you to know. But we need to talk more about the lab, right? So if I look at this sucrose structure, if I look at the chemical breakdown of sucrose, or really table sugar, because that's the particular type of sugar that we're looking at, table sugar is basically made from raw sugar. All right, so raw sugar, what does that mean? Well, that's kind of the big chunky stuff that's a little bit of brown in color that you would see sometimes at a coffee shop or a fancy tea place like Starbucks, right? So they can give you raw sugar, and some people will love raw sugar because it's not been touched by any type of chemical or any type of hand. So what are these chemicals that they don't like or that they hate? Well, table sugar, or the raw sugar in the beginning, is dissolved. And it's dissolved in phosphoric acid, folks. So if you've ever seen phosphoric acid in workings in a laboratory, this is kind of stuff that you want to stay away from. But, you know, they take very good care in your raw sugar, but they just need to dissolve the impurities out of it. Yeah, that's what I said. Raw sugar has impurities that are associated with it, and that's what gives it its brown color. And most people, they just want the sugar. They don't want all the other stuff that the raw sugar will bring with it. So that's why they dissolve it in phosphoric acid. And then they pass it through a carbon filter. And the carbon filter is kind of like your Brita filters or your pure filters that you have at home. So you send some water through a filter. These can even be the aquarium tank filters that's in the back of them, right? And these carbon filters will take out all of the impurities that might be present. Well, the same thing is going to happen here. They're going to take the raw sugar, dissolve it up, all of the impurities go into solution along with the sugar that you want in the first place. All of that gets poured through a carbon filter, and that carbon filter will reach out and it will grab those impurities just like it does in your water system when it comes from your faucet. And then they collect all of the stuff that comes through the filter, just like you collect it in your glass at home and you drink it. And what they do is that they dry and they granulate. The sample. And this is where we get granulated sugar. And this is what most people buy in the grocery store. The granulated sugar is typically that white, very small type of crystal sugar that we put in our sweet tea, or that we put in our Kool-Aid, or that we put in some type of drink to sweeten it up, or bake some cakes and cookies with it. So that's the majority of what people do. However, we do have a group of people that want the raw sugar, that do not want the chemicals that are associated with that type of process, and they will pay $5 and $6 and $7 and $8 for a bag of sugar, while I buy mine for $1.80 at the local grocery store. All right, so some properties about the sugar is that they are soluble in water. So what that means is that these things, most sugars, are very polar. That means they carry a charge, or their structure allows them to carry some type of charges that can associate themselves with water and basically break apart and stay dissolved in a solvent, such as water or anything else that's polar. Finally, we can talk about the melting points here. The melting point of sucrose, I'm going to say not available, because when you look at this in a chemical reference book, you're going to see the word called decompose. And decompose temperature for sugar, or table sugar, sucrose, is 186 degrees. That means when I reach it to 186, this thing will break down and it will completely change its chemical formula. It will not be sucrose anymore. And because of that, we can't really say that sucrose has a melting point, because that means that sucrose stays together as sucrose for the entire time until it turns into a liquid. Well, what happens in this case is at 186 degrees, sucrose will decompose. It will no longer be sucrose anymore. And to you, it might look like a melting point, but actually it's not really melting. It's completely changing into a different type of structure, and we can't really say it has a melting point for that reason. All right, so I want to take a look at the sucrose structure, and I'm going to bring it up here kind of on the screen to the side for you. That way you can take a look at it. And the sucrose structure is basically a series of carbon and oxygen and hydrogen. And I don't want you to memorize this structure, right? That's kind of silly to do. But I want you to take a look at the actual structure itself. So all of these OH groups that are on this molecule, those are functional groups. And an OH group is the functional group for an alcohol, right? Anytime in chemistry we see the OH group, we're going to say it has alcohol groups on it. And this has quite a few alcohol groups, right? We see 1, 2, 3, 4, 5, 6, 7, and 8. There's 8 of them in total, according to this drawing. And then if you notice, the drawing has taken specific notice to either draw the OHs pointed up or draw the OHs pointed down. And we're not really going to get into this part of the chemistry yet, but that is important because that's what makes the sugars different from each other. Are all of the OHs pointed up? Are all of them pointed down? Are they alternating up, down, up, down, up, down? Because that's really what's going to determine the type of sugar that we have, right? Or maybe sugar substitute if we don't want to use real sugar. Also notice that sucrose is a disaccharide. That means there's 2 pieces that are joining hands. Well, what do I mean when I say that? Well, look here in the very center. There's an oxygen right in the smack dab in the middle. And there's a ring to the left, and there's a ring to the right. This one is a 6-membered ring. If you count all the way around, spot number 1, spot 2, 3, 4, 5, 6. And the same thing's going to happen over here, but this is a 5-membered ring. So that oxygen spot 1, then 2, 3, 4, and 5. And this little piece is holding hands with this little piece through this oxygen that's in the center. We call that a saccharide bond sometimes. And this bond is pretty important when it concerns disaccharide chemistry. But again, we're getting too far ahead of each other, and we just need to kind of slow down and just take a general look about what this structure is and what it's doing. The reason that I'm picking out the OH groups is because these OH groups are very polar. Each one of those oxygens, and again, you'll hear me say this over and over and over, oxygen prefers 2 bonds. So this oxygen has one to the carbon in the ring and one to hydrogen. Those are the 2 bonds that it prefers to have. It doesn't want any more than that. What it does want, though, is to fulfill the octet like all the other atoms do, most of them at least. And for that reason, it has to have 2 sets of electrons on that OH group. So this set of electrons and this set of electrons create a very negative environment because remember, electrons are negative, right? So that means everywhere that OH group is, no matter where, I see negative areas in the molecule. So that means that this sucker is loaded with negative charges, which means that this is very polar, which means that it will dissolve in a very polar solvent, such as water. And that's why it does that. Okay? If you're into the mixed drink business, then good news for you because alcohol also dissolves sugar. So if you're making a simple syrup and you're adding that simple syrup to a drink, maybe your margarita, you're not going to see the sugar fall out of the solution. It's going to stay in the solution. And that's because alcohol will also keep the sucrose dissolved. All right? So that's a little bit about sucrose. Here on the screen to the left, and I'm going to bring this over a little bit more, you're going to see basically some sugar cane, right? You're going to see the raw sugar compared to the granulated sugar. This is the difference if you've never seen the raw sugar product before. And of course, the most common, I would say, label that you would see on a consumer product would be for Domino. Domino sugar is typically the brand that people always associate with when it concerns this field. But at the same time, I want you to understand that granulated sugar has been around for quite some time. And you can take a look at this old kind of box that shows Franklin granulated sugar in a 2-pound box, extra fine, which means that those crystals are ground up in really, really tiny, tiny crystals. So that way that they dissolve much better in your solution if you need to go that route. Okay? All right, so that's a little bit about sucrose. And in the next video, we'll continue on and we will talk about the next component, which is the aspirin component.